of a sudden I'm getting like 200 viewers a live. It's crazy.
That's insane, bro. Good. That's good.
Yeah, I don't know.
It's because...
It's it's boring. I say that.
What's that?
Some people don't like it in the comments, man. I'm not sure why.
Some people... I can't hear you. Sorry.
Some people don't like you in the comments, man. I don't know why.
Some people don't like me. It's because people don't like the concept that I push. I guess I don't know. It is what it is. Yeah. So what's up, man? Evidence that the Earth is a sphere. Or do you want me to? Do you want me to do it? Do my thing.
Well, I mean, I'm here for flat Earth evidence. So.
Okay. Water always finds its level. Let's start easy.
True.
Large bodies of water at rest always find their level.
So you have to shift the goalpost immediately.
No, you said that's not true, and I'm just correcting it.
Well, your first statement just wasn't true, but okay. We'll say large bodies of water find that have level, sure.
Okay, then the Earth's flat.
Well, no, because level doesn't mean flat. Level is just tangent to the direction of gravity. That's what level is.
Really? Because when you build a house, right, or when you like, 'cause I did a little bit of carpentry before, and I never built like a level anything that was curving. Never did that.
Well, that's because on the scale of a house, the curvature is almost non-existent, so you don't need to correct for it.
Oh, so when we build bridges, why do we make them level? Or pipelines? Pipelines are
again,
better.
long distances will be level because they're tangent to the direction of gravity. Because the Earth's curvature is taken into account already.
How do you measure it against gravity exactly?
What do we measure against gravity?
You said you had to make it in a tangent perpendicular to gravity.
Oh yeah, use a plumb bob. That's what's called plumb level.
Yeah, I know what a plumb bob is.
That's like the early level. That's like the very first level they had, like in medieval times.
Yeah, I know what a plumb bob is, but how do you measure it against gravity? How do you do that?
That's what that does, because the plumb bob will always fall in the direction of gravity. So that from there you can find a tangent.
How did you verify
that
gravity was pulling it down? How did you do that?
Well, then you need to prove gravity, which you have plenty of evidence for.
That's what I'm asking you for.
Oh, you got, I don't know, gravity lensing in space. You've got the Cavendish experiment. Those are the two main ones, I guess.
So you have lensing in space.
You've got gravimeters as well. You can see gravitational waves from space.
See,
there's plenty of evidence.
There's a category error in what you're saying, because you're saying Cavendish proves it, and you're saying that gravitational lensing is proof, but those are two different theories. But those are two different theories of gravity.
No, they're not.
Yeah, Cavendish would be Newtonian.
They both work in general relativity.
Cavendish would be Newtonian, and relativity would be gravitational lensing. So which one are we trying to prove?
Right, but the Cavendish experiment still works with general relativity. The theory is different, but the method is the same. They both prove general relativity.
Is general relativity trying to prove that mass attracts mass?
General relativity is... Well, mass attracts mass is a very simple way of putting it, but...
Is gravity trying to prove... I'm sorry, was Einstein trying to prove that mass attracts mass, or was he trying to compensate for the fact that F equals ma does not work on a cosmological scale? Which one was it?
Sorry, I don't know what you just said. You spoke too quick.
Okay. When Cavendish...
Anyway, why don't we stay... I mean, in regards to that, we're getting off topic of just level.
No, we're on topic.
Because we were talking about level, now we're talking about Einstein.
You're the one who brought up gravity.
Yeah, you were the one who said, how do we know it's gravity? And I said, well, you'd have to prove gravity with plenty of evidence we have.
Right, and you just conflated Newtonian dynamics with Einsteinian. So now we have to talk about that. We're on topic.
Yeah, well, Newtonian is just a simpler version of Einsteinian. They're not different.
Okay, if that's true, then why did Einstein have to remodel gravity?
What do you mean remodel gravity?
Because F equals ma, Newtonian dynamics, does not work on a cosmological scale. So Einstein had to come up with the theory of general relativity.
F equal ma.
It's Newton's second law of motion. Oh my god.
Our second law of motion. Well, sorry, I'm not very well versed in Newton's second law of motion. Okay, I'm sorry.
Oh, maybe you shouldn't try to prove gravity then. I don't know.
Force applied to an object equals its mass multiplied by its acceleration. Okay.
Yeah, mass times acceleration equals force, bro. Mass times acceleration equals force. That's what F equals ma is.
Yeah, force applied to an object equals mass multiplied by its acceleration.
Yes, yeah. I said F
That's
equals
what I just said.
ma, and anybody who's
Yeah, F
debating
equals
this
ma.
topic
Yes, I'm
should
with you now.
immediately. Yeah, no, you had to Google it. Anybody who's debating
Yeah, I know how to Google it.
gravity,
I'm not denying
yeah,
that.
F equals ma should be like common knowledge for anybody debating this topic, bro.
Okay, well, I'm sorry.
And
Now I know.
look up
So
if
how did that not work on a cosmological scale?
because you don't even I okay, Google it.
Well, I mean, you
Sorry.
tell me. Surely you know.
Because on a cosmological scale, the masses are different, and because you don't even have the amount of mass that would be required to move those objects, 99% of it is missing. That's why you have dark matter.
Okay, so it doesn't work. Sorry, run that through me again.
Even
Run me
with
through that again.
Even with Einstein's field equations,
No, 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 no,
99
no, no, no. Ignore that for now. Why did Einstein have to change it? Why does F equal ma not work on a cosmological scale?
because the amount of mass is not observed. The amount of mass
The
that
amount
would
of
be
mass is not
required,
observed.
yeah, because the amount of mass that would be required to move an object in its orbit is not observed. We don't have the same amount of mass to because we can measure how fast they're moving. You agree to that, right?
Yes.
Okay.
Mm-hmm.
Well, based on how fast they assume them to be moving, there's not enough mass of the object that they assume, right? They assume the amount of mass, they assume the speed, and they aren't directly
Mm-hmm.
proportionate. Because there should be an
Okay.
inversely proportionate. Because what's the second law of motion? Okay, and you don't have to Google this, I'll just tell you. An object's acceleration is proportional to the forces acting upon it and inversely proportional to its mass. So there's an inverse proportionality. Okay? So when you look at the object and you say, hey, there's a lot of mass there, but it's not enough to cause it to move in the direction that it's moving at the speed at which it's moving, right? So that's why Einstein had to come up with relativity. And even that doesn't work because they still say look up what dark matter is.
Yeah, I know what dark matter is.
What is it?
So what happened was they had a theory, they realized an error in the theory, then they changed the theory to now max reality, is what you're saying happened.
What is dark matter? You just said you knew what it was.
But dark matter's kind of even science doesn't fully know what it is yet. It's kind of it's like the stuff in the universe that's forcing it to expand.
No, that's dark energy. That's dark energy.
Oh, okay. Well,
dark energy is the cosmological constant. That's
right. So what is dark matter then?
It's your belief system, bro, that I'm teaching you in front of 200 people. You realize that, right?
I mean, why did you ask me that question if you...
Because it's unanswerable. Because it's unanswerable. You don't know the answer. That's why
I was correct in saying they don't know what it is yet.
I'm exposing you.
So you're not really exposing me because science doesn't work off of it doesn't work off of like proven truth. It works off of theory and like building up a theory.
Did you just say science doesn't work off of proven truth?
Yes, science works off of like building up. It's never to do with proof. It's evidence-based conclusion is what we go with, not like certain like truth or fact.
Conclusion? How do you arrive to a conclusion if you only postulate on it?
It's not postulation, it's evidence. They use evidence-based conclusion. That's what gravitational theory is.
Where's the evidence for dark matter and dark energy?
Well, it's clear, obviously, that like, as you said, right, there was clearly an error in the F equals ma, so they've come up with, okay, well, clearly there has to be some other matter going on here.
Or your model.
Again, it's still a not fully fleshed out theory. Bro. I'm not disagreeing with you.
Or your model's wrong, considering do you realize it makes up 99% of all mass in the universe?
Okay.
That's what dark matter is. So if I gave you $1, right, and I said,
and if that's the case, then everything else works. So I mean, again, I'm not disagreeing with you. That's not like a fully proven theory. I'm not disagreeing with you. I'm saying obviously there still needs work. That's how science works. Science builds theory on top of theory. That's how it works.
So it's unfalsifiable. That's brilliant.
It's not unfalsifiable. You could have an observation tomorrow which debunks the entirety of general relativity.
Just let me.
But no one has made an observation like that yet.
Just let me steelman your position, okay? Right?
I mean, do you have flat Earth evidence for us?
I will.
All you're doing is you're disproving the globe. You're not proving the flat Earth right now.
I'm not trying to. Oh, you want to obfuscate now? You want to shift the goalpost?
I'm not shifting the goalpost. I'm just the whole point was bring evidence.
I told you water always seeks.
That's why I was asking for flat Earth evidence, not globe denial.
I told you water always seeks its level, and you brought up gravity.
Yeah, and I told you that's not. I told you level just means plumb.
Level doesn't mean plumb. You said it was perpendicular to a pseudo-scientific
tangent
force.
With the direction of gravity, yeah.
You said it was perpendicular to gravity.
Yes, right? Tangent to the direction of gravity, which is plumb level.
Which is why we're talking about gravity that you know nothing about.
Well, I don't know the specifics.
No, you don't know anything. I guess, but... So what's it perpendicular to?
To gravity. Which is downward force on Earth.
What is it?
Downward force on Earth.
That's downward acceleration towards Earth. How do you know that that's not an electrostatic phenomena?
Because otherwise we would see difference depending on the material.
No, you wouldn't. There's an electric bias in the atmosphere. That's what causes it.
Yeah, but if it was causing a downward force, we'd see different accelerations depending on how the material would interact with that electric force.
It's not. Sure. It has nothing to do with the material. It has to do with the components of the atmosphere. And you do see a change in the 9.81 meters per second squared. It can go from like 9.77 to 9.83 sometimes, depending on places, depending on elevation, depending on location, depending on whether there's an electrical storm. There's a lot of things that interfere with that assumed to be average constant, right? So you don't have like any evidence that it's gravity because 99% of your universe is missing just to compensate.
So what evidence do we have that it's electrostatics?
The electric atmosphere. Look into Richard Feynman. Richard Feynman 9.1. I can send it to you.
Well, I mean, we know gravity exists because electrostatics can't explain the Cavendish experiment.
Dude, I would love to break that down for you. Everything on a molecular level is intrinsically electrostatic. Everything.
Yes, we know that.
Okay, and you can transfer electrostatic potential to an object when you touch it, and an electrostatic potential can be transferred through the atmosphere itself.
Are you talking about
I love how you asked me to explain this. I'm sorry?
Yeah, no, I'm just making sure we're on the same page. Are you talking about polarization?
No, I'm saying that on a molecular level, everything is intrinsically electrostatic. Okay, so when you touch an object, you can transfer the transfer of electrostatics can happen, whether it be negative or positive. Like, you can go in or out, right? And when you have two lead balls on torsion bars for multiple fucking days, which is how long it usually takes to get results with Cavendish, there's no way to completely isolate and eliminate the variable of electrostatics. And there is an electric gradient in the atmosphere. This is Richard Feynman 9.1. I can literally send it to you.
Okay. So do you think that maybe grounding the apparatus would not remove that electrostatic thing? Would that not happen? Or am I incorrect in that?
Can you repeat that?
Would grounding the apparatus not remove that electrostatic gradient, or am I incorrect?
Would it remove the electrostatic gradient from the atmosphere itself? No.
No, not from the atmosphere. No, from the balls. Would it remove the charge?
No, that's just are you removing every single atom?
No, but there still needs to be a net positive or negative charge for an attraction to take place.
No. This is where the confusion on your end is. It's not a positive and negative charge from the masses themselves. It's a positive charge from the atmosphere pushing down towards the negative charge of the Earth. The atmosphere is positively charged 100 volts per meter. Okay. And the surface of the Earth is negatively charged up to 400,000 coulombs. So as that, it's like rain, like pushing down constantly. There's diagrams for it. Richard Feynman 9.1. I will send it to you.
So that's what I'm saying. I don't understand as to how, like, charged objects wouldn't interact with the positive atmosphere differently. I mean, would negative things not be attracted to the air rather than the floor?
No, you would need an incredible amount of charge or lack thereof.
Really, something in like a Faraday cage, not stuff floating?
It still works under density and buoyancy. Like, if something's more buoyant than its medium, it's still going to go up. But things are attracted towards but things are attracted towards the Earth. This is why they call it grounding.
Yes, because of gravity.
What? No, this is steelman my position.
Why?
Because you don't understand it. Steelman my position.
Yeah, so one moment you were saying it was electrostatic, saying that there's like an electrostatic downward force pushing things to the floor. Then you said, oh, actually, no, it's density and buoyancy. So make your mind up.
No, I didn't say that. It still works under density and buoyancy, right?
It doesn't, because density isn't a force and buoyancy requires gravity.
Listen to what I'm saying. Listen to what I'm saying without interrupting me for 1 second, okay? There is an electric gradient in the atmosphere that has an effect on all mass. Okay, outside of that, it just whether an object goes up or down is relative to its buoyancy or density within the medium that it is in.
Buoyancy requires gravity.
Buoyancy requires 9.81 downward acceleration. That's all it requires, which I'm giving you with
which is caused by gravity.
Which I'm giving you with an electrostatic downward bias.
Okay, so then again, how would a charged object not interact differently with the downward force?
That's not what I'm saying. It's the atmosphere pushing down on the Earth.
Yeah, I know, but because the atmosphere is positively charged, pushing down on negatively charged, surely if something was either isolated from that atmosphere, right, or if something was charged,
you can't isolate something from the atmosphere. You can't do that.
Well, so you can't put something in a vacuum chamber?
You don't eliminate the entire atmosphere.
You could eliminate it to a very severe degree.
You can't eliminate the entire atmosphere.
But we see. Okay, so if we put something in a vacuum chamber, there's less atmosphere. Agreed?
Yeah.
So surely there will be less of a downward force.
If there's less
atmosphere, there'll be less downward force.
No, there's less atmosphere.
Why not?
There's more air. There's less air resistance.
Yeah, no, because you're saying the downward force comes from the charged particles in the atmosphere pushing down on the Earth, correct?
That's my understanding of it.
Okay, so if there was less atmosphere, there'll be less charged particles, meaning less downward force, correct?
No.
Why not?
Because it's a gradient. It depends on your altitude.
Yeah, no, if we're doing this on ground level. If we have a vacuum chamber on ground level,
I don't know. We
remove the atmosphere, there would therefore be less downward force because there's less atmosphere in the vacuum chamber.
You would need a vacuum chamber that was hundreds of meters tall to even measure something like this.
Why?
Because how else are you going to get a consistent downward acceleration? Do you know how downward acceleration is measured?
9.8 meters per second squared is the current.
Do you know how it's measured? Do you know how it's measured?
Well, I mean, it doesn't necessarily have to be hundreds of meters tall.
You have to drop something from various altitudes.
Yes, I know that, but I mean, if it's entirely based on the atmosphere, surely we would see an immediate effect regardless
of whether it's 500
meters tall or two.
Dude, the biggest vacuum chamber, I don't know how big it is, but I don't think you can even like...
Okay, well, I mean, we can look at the NASA, NASA has a huge vacuum chamber, which they test things in. They can drop something from like 50 meters high, and we see that it still accelerates at the same rate.
50
surely
meters,
we would see some kind of decrease.
Okay, that's one location where you could do it, right? But you would need more than that.
But in that location, we see no decrease in fall whatsoever. We see everything falls at the same rate.
Everything doesn't fall at the same rate, no matter what. Dude, listen to what I said earlier, right? It fluctuates depending on location on Earth. It fluctuates based on elevation, and it fluctuates based on, get this, electrical storms. Why do you think that is?
Yeah, I know that, but you're saying it's still caused by the atmosphere. If we remove the atmosphere, it will affect the rate of things which fall.
Oh my God.
Which we see doesn't happen.
Yeah.
But that doesn't happen.
Oh my God.
We see when we remove the atmosphere from a vacuum chamber in NASA, which is like 50 meters tall, we drop something, we see it falls at the same rate as it always falls as, if not faster, because there's no air resistance.
It doesn't fall at the same rate, they fall at similar rates. It doesn't fall at the always 9.81. They fall at the same rate. I'm not saying
it's 9.8 meters per second squared. In the same location, it's always the same rate.
In that
NASA chamber, it's always the same rate.
So you're the one shifting the goalpost now.
How am I shifting the goalpost?
It has to be in the same location
this whole time.
Let me finish before you interrupt me again. So you're insinuating that we drop things from the same altitude at the same location, right? I'm saying that that's not how it works. You have to change locations, and you have to change the height of the object that you're dropping at the altitude, which is my point from the very beginning.
That's not the point I'm trying to make.
Interrupt me. You had to interrupt me.
No, because you're misrepresenting my point.
I'm representing how it actually works in reality. You're misrepresenting your own fucking
Yes,
gravity.
I know it might change it, but no, I'm saying a test you could do to prove whether this is the case or not. That's what I'm saying.
That doesn't that doesn't incorporate all of the variables, bro.
Yeah, it doesn't need to. Right? Because you're saying...
Oh, God, I'm so glad that you said that, bro. I'm so glad. Because you're just exposing yourself.
No, you're saying that the downward force is reliant on the atmosphere being present. That's what you're saying. If we remove the atmosphere, there'll be no downward force.
You can't remove the atmosphere, bro. You can't do it.
Yes, you. What do you think? What do you think vacuum chambers do?
What is nothing?
An absence of something.
How? Give me an example of nothing.
A vacuum is a vacuum is a good example. It's almost entirely devoid of matter.
Almost.
Yeah, there is no perfect vacuum.
Then what is okay? There is no perfect vacuum.
So
thanks
we
for
would
playing.
Still expect to see
now.
We would still expect to see if there's less atmosphere, there will be less downward force. That just makes sense, right?
No.
That logically
it
follows.
Does sometimes change in an atmosphere devoid of a lot of matter anyway. Why do you think things allegedly float in space? This is all your claims, right? There's less gravity in space.
Things float in space because they're in free fall towards Earth.
Isn't that what you guys always say? There's less gravity in space because it's a vacuum, blah, blah, blah. It's literally you're arguing against yourself.
No one says that. No one says that. What are you talking about?
Oh, dude, he doesn't even know his own position. You shouldn't be doing this, bro.
No, people don't float in space because of no gravity. They float in space because they're free falling towards Earth. It's the same thing as like when you're in one of them gravity planes and they free fall towards Earth. Then you're weightless. Yes, of course.
Is there gravity in space?
Yes.
Coming from what?
Coming from everything.
Coming from what? Gravity requires mass. Where's it coming from?
Yeah, mass. Everything.
Yeah, where's it coming from? If you're in a vacuum, where's the mass? Where's the mass that's attracting you?
Are you talking about a perfect vacuum which doesn't exist?
Dude, you can make the vacuum however you want. Just answer my question. If there's no mass in a vacuum, where's the attracting force coming from?
If there's no mass in a vacuum, then you're not in the vacuum because you are mass.
Oh my god, dude.
So it's a pointless question.
Dude, you can't answer it.
Well, no, your question makes no sense. Where's the mass coming from if you're in a vacuum?
So
it's obviously coming from you then, I guess.
Gravity changes in a vacuum? So gravity changes in a vacuum?
No, gravity doesn't change in a vacuum.
Is there gravity in a vacuum?
But space is a vacuum, right? There's still gravity in space because there is still stuff in space.
I'm not
sure what you're getting at.
What's pulling you?
What's pulling you? The stuff in space.
What stuff? The lack of stuff? The privation of things?
Planets.
From where? From where?
What do you mean from where? From the planet.
Then, okay, so if the sun's pulling us, why don't we get closer to it?
Because we're in free fall around the sun. Because we're going at just the right speed where we're moving this way and towards the sun at the same speed, so we're going to curve path.
Bro. I need you to backtrack because the audience might not have caught that. That was funny. So gravity doesn't change in a vacuum, right? That's your claim?
No.
Now it's not your claim. What's your claim?
Well, no, I meant that like gravity doesn't change in a vacuum, right? Because space is considered a vacuum other than like the planets and stuff inside of it. So no, gravity still acts the same. If there's mass, there's going to be gravity. Doesn't matter what medium it's in.
So when you eliminate the atmosphere, or at least most of it, does it change how objects interact in a vacuum? Do objects change?
No, they still fall down.
What's down?
I've only talking about on Earth. Sorry. I mean, if you're in a vacuum with no mass, then there will be no gravity.
Do you have evidence that the Earth is curving? Maybe we should just simplify this, bro. You can call it. I'm
you're here to convince me the Earth is flat, brother.
Okay.
You're here to convince me the Earth is flat.
Do you want to try to? Did you look into LoRaWAN since we last spoke on it?
Yeah, I did. Yeah.
Well, yeah. How does it work?
Atmospheric ducting or something. I heard was the best explanation for it.
Oh yeah, tropospheric ducting. So it penetrates the ionosphere and then bounces off the troposphere. That's what you think is happening?
Something like that. So I didn't look too deep into it, but that was the best explanation I heard.
Okay, so if it bounces, that's a
good point, Iceman. Why are you talking about the globe? But sorry, carry on.
So I don't believe in this stuff. This is your man. You forget that I'm steel manning your position, right? And then you're like, well, that doesn't make sense. I'm like, I know, bro. I know. I'm steel manning your shit. Regardless,
yeah, go on.
When you penetrate the ionosphere and then it bounces off the troposphere and then it like ping pongs around, bounces up and down, propagates, right? In between both of those. So why does it penetrate the ionosphere the first time and not the second time when it bounces back down?
It's because of a what's the word? Density gradient.
The density gradient? Explain that to me.
Well, that's how refraction works. If there's a density gradient, something will refract.
It's not refraction. What are you talking about?
That's what atmospheric ducting is.
Just exposing yourself so badly right now.
Well, I'm sorry, I haven't looked into this specific thing very deeply, but I mean, I was talking just fine with you.
Hoping that they're gonna.
I'm not just saying words. I'm just saying my best understanding of it. I was talking with you perfectly fine for the past 20 minutes. We've been talking.
Dude, you've been all over the place this whole time.
I haven't been all over the place. I've been perfectly. You're the one who's been all over the place. I said, surely if we have less atmosphere, we would have less downward force. And you said, oh, well, actually, no, because this and that. And then I said, and then you moved on to vacuums, and then you moved on to would gravity change in a vacuum?
And then I proved it.
You didn't prove anything to me.
And then I proved it to you using your own belief system.
How did you? Okay, so why would there be no difference in downward force if the atmosphere is responsible for our downward force in a vacuum?
Repeat that to me. I'm sorry, I didn't catch the first part.
Sorry, yeah, no, I kind of marbled that. If the atmosphere, the charged particles in the atmosphere is responsible for our downward force, why would there be no change in the downward force if we remove the atmosphere in a vacuum?
I'm assuming that it would be hard to verify if there is or isn't. But this is my claim.
It's very easy to. We can drop a ball in the atmosphere, then we can remove the vacuum. We can create a vacuum, then drop the ball again. We see they drop at the same speed.
Okay, but you don't actually change it from location to location, and you don't change it from altitude to altitude.
You don't need to. You don't need to.
Right, you don't.
Because you're saying the atmosphere is responsible. If we remove the atmosphere, surely the downward force will change, regardless of where you are.
Are there variables in science?
Yes, of course they are. Of course there are variables. So that doesn't negate the fact that it should change. How do you just
not compensate for variables in science and just say that's science?
Well, no, because that doesn't negate the fact. Just because it's variables doesn't negate the fact that we should see some change in the downward force. That doesn't negate that fact.
There's a lot of variables in this, bro.
Yes, I know there's a lot of variables. Can you answer the question now? Why does the downward force not change, even though it should?
I'm assuming it does.
It doesn't. If anything, it goes faster because there's no air resistance.
Where's the evidence that it doesn't?
Would you like me to pull you up a NASA video of them dropping a bowling ball and a feather?
That's not measuring downward acceleration. That's measuring objects falling at the same speed.
No, they do actually measure the downward acceleration of it.
But that's measuring them down. That's measuring them falling at the same speed because you negate air resistance.
Yeah, I know. And the bowling ball falls at the same speed as it did beforehand.
How do you know
before the vacuum?
How did you verify?
I don't know,
because
you can see it. What do you mean? And I'm pretty sure they measured the speed as well.
It's camera cuts, bro. It's like cut up like a piece of toast. Anyway, what was the original?
You still haven't answered my question. You still haven't answered my question.
I would need more concrete data before I believe your positive claim.
Okay, well, where's your positive claim?
That the Earth is not curving?
Your claim was, right? Your claim was, right? Oh, well, it's actually, it's because of the charged particles in the atmosphere. Where's your proof?
I offered to send you Richard Feynman's 9.1. You can read it yourself. Richard
Feynman's 9.1.
I'll send it to you, bro. It's long. You're not gonna even be able to read it all. Unless you want to.
The electron mass is 9. Is this the electron mass? What is this about?
No.
I mean, yeah. Just. I mean, can you summarize it for me?
Yes, I already did 4 times. There's an electric bias in the atmosphere. The atmosphere is electrically charged positively. 100
yeah, no,
you'd
have to prove that would cause an attraction downwards. That's what I'm saying. Can you prove that it's because of the atmosphere and not because of gravity?
I have to prove that positive attracts negative and vice versa?
Yeah, you'd have to prove that the downward force we see on Earth is because of that and not because of gravity.
Yes, I can send you also multiple PDFs that completely replace the kinematic and dynamics of what we call gravity and the mathematics. You can derive 9.81 and big G through electrostatics. I have multiple PDFs for each of these.
Yeah, because you'd have to prove electrostatics is the source and not gravity. You'd have to prove that's the source.
Remind me exactly why we're trying to prove gravity.
No, I mean you're trying to prove your electrostatic theorem to prove the flat Earth.
Do you remember my original argument when I first came up here?
Your original argument. We were talking about water and how water is level.
Yeah, and you brought up a plumb bob, and you're trying to say that level means curved, and I'm saying no, that's dumb.
Level means tangent to the direction of gravity. Yes.
Yeah, I know. Level means curved, which I say that's stupid right? I'm saying level is level, which means no point higher than another, right? That's what level means.
There isn't on a globe either.
We're not on a globe.
Right, well, that would still fit your definition of level. There's no point higher than another on a globe.
Are you okay?
Minus topographics.
Do you know geometry well enough to debate this topic?
Well, okay, on a sphere, what point is higher than the other point on the sphere?
You could take a point at the equator and the point at the North Pole would be higher.
They'd be at the same level, though.
See how easy that is?
No, they'd be at the same level. What are you talking about?
If I'm looking at a sphere and I put my finger on the right side of that sphere where the equator would be, and then I put my other finger on the North Pole.
Okay, I guess you're right. That's fair enough. I guess you're right. But but yeah, it's kind of my bad. But still.
Yeah, you can't do this, bro. You need to stop. You need to stop. You're actually one of the most intellectually honest globers that I'll meet. But I'm serious, bro. You need to really reconsider doing this. Because you can't...
I mean, I think I've been talking with you perfectly fine. Man. Huh? Yeah, I made one mistake. I'm sorry. Okay, Christ.
No, dude, this whole thing for you is a mistake. The Earth's not a globe, and you're trying to
Brother, you still can't explain to me as to how the fucking atmosphere doesn't disappear and then suddenly things don't fall down. You still can't explain that. You haven't explained it. You said, "Oh well, Richard Feynman said this," but you're not actually explaining it. You said, "Oh, there's we know there's an electric gradient in the atmosphere. We know that, right?"
If you read some stuff, right? There's an electric charge in the atmosphere that is positive. There's the surface of the Earth.
Yes, I know that. You've already explained that, but you haven't said as to how that is actually what's occurring and not gravity, because we know gravity exists.
You need to let me finish.
Okay, go ahead and finish.
All right, bro. Positively charged atmosphere, negatively charged surface of the Earth. Positive attracts negative. This has an effect on all mass. Everything that is made of mass is going to be affected by this. Okay, then it's just density and buoyancy from that point forward.
How do we know it's that causing 9.8 meters per second squared and not gravity? That's what I'm asking for.
Because electrostatics and electromagnetism is 10 to the 36 times stronger than gravity even claims to be. And when I have, this is a perfect example. When I take laundry out of my dryer, right, and the dryer sheet sticks to my arm, that's not gravity, bro. That's electrostatics.
Yeah, I know.
So we know that electrostatics can cause things to retract and repel and pull, right? And we can. Okay,
sorry, I'm cutting you off again. I know. But if it is always electrostatics causing things to fall downwards, why did there something stick to your arm and not just continue falling downwards?
Because there's an electric force that's pulling from your arm. Like you've given it more electrostatic potential.
And you say that force is stronger.
Eventually, that will work off. What?
Yeah. Yeah. Okay, but I mean, could it be the fact that it's stuck to your arm and that's electrostatics, like you say, but it could just be gravity pulling it down at the same time, right?
I'm just saying, bro. You have evidence of electrostatics. When was the last time you had anything?
Yeah, but you have plenty of evidence of gravity as well.
When was the last time you had something stick to your arm because of gravity?
Never, because that's not how gravity works.
Exactly. When was the last time gravity was isolated as an independent variable in an experiment and proven to be the cause for downward acceleration?
Cavendish experiment.
It wasn't isolated.
It was isolated.
Dude, what was Cavendish originally trying to do?
I don't know. I only know the modern Cavendish experiments.
He was originally trying to prove the mass of the Earth, or the density of it.
Okay.
I'm just saying, bro, like you reference these things, these hit points, but it's like so copied and pasted and regurgitated that it's almost not even.
Yeah, no, I know how the modern Cavendish experiment works. I don't know his original goal with that, but I mean, again, that doesn't change the conclusion he came to.
Trying to prove that the Earth.
So what? It doesn't claim that doesn't change the conclusion he came to.
No, actually.
Just because he set out doing the experiment with one idea in mind and he came to a different conclusion, that doesn't mean anything. He still came to that conclusion.
So here we have I have to shift the burden of proof towards you, bro. Do you have anything else that proves that gravity is the cause for downward acceleration? Because my argument's recreatable and testable. Yours is not.
So is mine. The Cavendish experiment is recreatable and testable.
To prove you're not isolating for electrostatics, though. You're not doing it.
You are. You ground it, and we know for a fact polarization wouldn't cause that, and electrostatics wouldn't magically cause that either.
It's not polarization, dude. It's positively charged atmosphere pushing down on the Earth. And then it's just density and buoyancy.
Yeah, but those lead balls wouldn't attract each other. Then why do the lead balls attract each other?
This is why you don't understand.
Why would the lead balls attract each other? We're talking about lead balls attracting each other.
This is why you don't understand, because you convince yourself that you know what I'm going to say, but if you just zip it for a minute, I will explain this one more time for you.
Yeah, I know there's a positively charged atmosphere and negatively charged Earth. We're not talking about balls going down. We're talking about balls being attracted to each other.
Right. You didn't fully isolate for electrostatics.
We don't need, if it's just causing a downward force, we don't need to, because we're attracting the balls to the balls, not the balls to the floor.
Dude, you leave. How long does Cavendish typically take to gather results?
It could take a few hours.
It can take up to a few days. And
it depends how you do it. You can do it.
How are those results? How are those results measured? In what metric?
Well, there's different ways of doing it. I mean, there's one way. If you do it very simply, you can just see whether they simply attract each other or not. Another one is
how would you measure?
They do it with like a laser.
How do you measure it? How do you measure it? Using what metric?
You measure how. You measure. Well, I mean, you can do it in millimeters. You can see how much they're attracted to each other by the movement that they have.
Precisely, bro. It takes multiple days for it to move a few millimeters, which could be caused. Yes, sometimes it does, and it can be caused.
Yeah, sometimes it does. Sometimes it doesn't. Sometimes you can do it in a day. Sometimes you can do it in a few hours.
Great. So
depending on the size of the lead balls.
So it still takes an exceedingly long amount of time to move something.
How's that exceedingly
you cannot let me finish, bro. You're impatient. Just listen.
Because you're saying stuff that's wrong. Like, you're saying stuff that doesn't make sense.
It takes extended periods of time for something to move a few millimeters. That proves nothing. That proves nothing. That does not prove gravity. If it was gravity,
it proves that gravity scales with mass. And you can see that the bigger the lead balls are, the quicker they attract each other.
Why don't you scale up the Cavendish?
I mean, they do. There's different sizes of Cavendish experiment. And you'll see that the bigger the balls are, the quicker they attract each other.
Show me.
Well, I don't have that on hand.
Oh. So that's baseless.
Your shit is baseless. You haven't showed me anything.
I've been able to. I can send you all this stuff, and I will. I'll send you all this stuff.
I'll be happy to send you those videos of 2 different Cavendish experiments.
You're gonna send me videos, and I'm gonna send you documents and PDFs and articles. But okay, there's category error there. Interesting.
I can send you PDFs. So can we go back to LoRaWAN experiments being performed?
Can we go back to LoRaWAN so I can steelman that real quick? What you think is happening?
Sure.
Okay, so you think that a highly potent electromagnetic beam of radiation is penetrating the ionosphere as it goes up, and then it bounces off the troposphere, and then it doesn't penetrate the ionosphere again for some reason, it just chooses not to. Then it bounces up, hits the troposphere again, bounces back down, chooses not to penetrate the ionosphere again, even though it's perfectly capable of doing so.
Well, I don't know whether it's in the ionosphere or not. I'd have to double check that.
I'm steelmanning your position, bro. I know what your claim is. I know what your claim is, and you don't. That's funny.
Well, so I had to double check it again. Like I already told you, I only did some cursory research on it. I'm clearly not as informed on this as you are. I'm happy to admit that.
Maybe you should be. If you're
not on this specific one, I'm not very.
I mean, you claimed it was refraction. You claimed it was refraction. Can I finish steelmanning your position?
That's what atmospheric conducting is.
It's not.
It's a form of refraction.
No, it's not.
Do you want me to Google it?
It's a form of propagation.
Let's have a look. Atmospheric duct, blah blah blah. Mode of propagation, usually in lows.
I just said that.
By atmospheric where the waves are bent by atmospheric refraction. So we're both right.
Propagation. Propagation's not refraction.
Yes, by refraction.
What is propagation? What is propagation?
It's a mode of travel.
You just Google what propagation is.
Propagation.
You might as well go to images.
Transmission. So yeah, mode of travel.
Go to images when you type in propagation. It's like an up and down V-like pattern.
Let's just show me images of plants. Show me images of plants. It's a mode of travel. It's transmission. I think we're on the same page.
No, propagation is when something bounces off of one thing and then bounces back down off of another surface. Like you would have like a laser.
That's not what Oxford Dictionary tells me. I mean, that's not Wikipedia. It says, is the behavior of radio waves as they travel or are propagated from one point to another in a vacuum or into various parts of the atmosphere?
It's a mode of travel.
Like a propagated
to you. Oh my god, it's a mode of travel. I don't disagree with that.
Yeah, I know. That's what I just said. It's a mode of travel.
That's very vague. That's what I just said. But that's very vague. Okay.
That's what it is.
That's like saying a mode of travel
propagation,
is being on a bike.
Transmission of motion, like sound expector in a particular direction or through a medium.
Do you have any patience?
That's just Oxford Dictionary.
Do you have any? You just admitted that I knew this better than you, so please let me elaborate on what it actually is.
Okay, good. I mean, do you have like a link, like for the definition you're bringing up, or what?
I would assume it would come up if you typed it in. I guess maybe you'd have to be a little bit more specific. I can send you some more stuff on that as well. Just like when it's like ping pong, bro. It bounces off of one surface and then bounces off the bottom surface, and then this pattern repeats. Are you listening to me?
No, I am listening to you. You're saying it ping pongs, but this isn't what's coming up. It just says behavior of radio waves as they travel or propagate from a transmitter to a receiver.
But can you picture it though? Like if you launched a beam on Earth, it was a sphere, right? It would have to bounce off of the atmosphere and then come back down. They claim that it usually bounces off the surface of the Earth again.
Yeah, no, that's
this pattern repeats.
That's propagation in atmospheric ducting. That's not propagation in general.
Dude, we're talking about atmospheric ducting.
Yeah, I know, but you're just saying. Sorry, maybe I'm misunderstanding you. Maybe you're saying that propagation. I thought you were saying that propagation is only is only the mode in. Sorry, I maybe I misunderstood you or something. I don't
know. All right. I guess I don't know, dude. You're gonna have to just figure this shit out. The Earth's not curving unless you reify and reaffirm what you already believe through pseudoscientific means, which is what all of you guys do. And you're I can't.
Have I said pseudoscience anywhere?
Yeah.
Have I said pseudoscience? Which one? Name one.
When you said that gravity wouldn't decrease when you were in a vacuum, that's pseudoscience.
How so?
Because there's no mass in a vacuum, bro. I gotta go. You have a good day.
Take care. Yes, in a perfect vacuum which does not exist, there will be no mass.